have a few things we're going to need to do in this problem to figure out what kind of triangle we have formed when they give us 3 coordinates. I've gone ahead and already plotted my 3 points and labeled those points so I can see my triangle. Now, as we talked about, it's not enough to just look at this and say, yeah, it looks like a right triangle or it looks acute. That's not going to be good enough. We need to use math to justify our answer and explain our answer. So what I'm going to need to do is, well, unfortunately, the bad news is the first step is I need to find the distances, the lengths of all 3 of these sides. I guess the good news is we have a way to do that. We do have the distance formula that d equals the square root of, x1 minus x2 squared. Hopefully you have that in your notes. It's a long problem because you need to do that 3 times. You need to find the distance from A to B, you need to find the distance from B to C, and then you need to find the distance from A to C. You can do it, it's not torture, it's just kind of obnoxious to have to do that 3 times. So what I did was I actually used the distance formula program I had built into my calculator and that I gave you guys in class to help out and save some trouble with this problem. So go ahead and use that program if you do have it. If you need it, talk to me. If you don't know how to use it, talk to me. If you don't have it, well, get out a piece of paper and start doing the distance formula 3 times. So to save time and to make this not a 10-minute long video, I'm going to go ahead and tell you what I found out for the 3 distances. And notice I'm using the exact numbers. I'm not using decimals, and that's going to be key to these. If I use decimals, I may I'll have rounded answers possibly, and I may not get the final correct answer when I'm done. So I found the distance from A to B to be the square root of 26. I found the distance from C to B to be the square root of 20, which I got from the calculator. Now that's not simplified, although for what we're doing, it's okay to leave it like that, although the simplified answer would technically be 2 square root of 5. And then the distance from A to C is the square root of 10. Once I have those 3 sides figured out, now I can go do what we've been doing in the past to figure out what kind of triangle this actually is. So I'm going to test the Pythagorean theorem. My smallest side is the square root of 10, so I'll call that the A. Notice I'm using parentheses. So the square root of 10 squared plus my next biggest side was the square root of 20. If you didn't happen to know whether that number was bigger or smaller than the other numbers, you could use a calculator and make these into decimals, but again, use the exact values, use the square root values when you're plugging these in, so we're not making a rounding error. So there's my 3 sides set up with that box in between because I don't know what kind of symbol I'm going to be using. When I square a square root, they just cancel out. So the square root of 10 squared is just a regular 10. The square root of 20 squared is just a regular 20. That's why I said we didn't need to simplify it. And then the square root of 26 squared, again, those just cancel, is a regular 26. I can see it's not going to be right because look what's happening. My 2 sides are not equal to each other. If I had a right triangle, I'd have the 2 numbers equal to each other. Rather, I have an inequality symbol, and of course 30 is bigger than 26. If those 2 values of the 2 smaller sides squared are bigger than the third side squared, that tells me I have an acute triangle. Again, I know I saved some time using that distance formula. If you need help finding those distances, not sure I did that, send me an email or talk to me in class.